All right, hello everyone, this is Mr. Crozier. I'm going to go over review set number 1 with you here. All right, first problem, we have this expression to simplify, and if you notice, this 1 plus tangent squared is on here. 1 plus tangent squared is secant squared, so I went ahead and made that switch, and then I went ahead and changed secant to cosine, and then they cancel out to 1. On number 2, it's already set up for you, so you can go ahead and split it up into a left function and a right function, both of them set equal to 0. Then you go ahead and solve it. Make sure you draw these little diagrams. They help you pick the right angles, especially on this one. All of these angles are perfectly 90 degrees apart. So I could just say pi over 4 plus pi over 2, k, or the letter n to get around there. On number 3, we have to find this cosine double angle. Well, for cosine double angle, you have all 3 of these options here. But before you use those options, you're going to have to draw a triangle. So if I draw this triangle, now I can pick, well, what's my cosine? Negative 4/5 squared. What's my sine? 3/5 squared. Then I can do the math. On number 4, I went ahead and, again, there's another identity. Anytime you see those squared identities, think about these Pythagorean identities. You can simplify it in, change it to sines and cosines, and do the work. Number 5 here. On number 5, I went ahead and I looked at both of these terms, and I noticed that they both had a same factor in there, so I factored out that cosecant, and now I have cosecant times 1 minus cosine. Well, that's sine squared, and those cancel out. On the next one, number 6, this last part's easy to do because the sine of 30 degrees is 1/2. 4 times half is 2. But what am I going to do with this? Well, that's cosine of A minus B. And I'm going to use this formula here. Cosine of A minus B. Cosine A, cosine B, plus sine A, sine B. Right down to there. Then you do all those parts. It comes out to negative cosine plus 2, or plus 0 plus 2. I went ahead and put the 2 at the front, subtracted the cosine. All right, on number 7, I could use this identity here that says sine of A minus B. However, it's a cofunction identity. It does match this one exactly, so I can use this one. And that's a cosine on top, 1 cosine on top, 3 on the bottom. Cosines divide out. I'm left with 1/3. On number 8, all 3 of those values are on the unit circle. So I went ahead and just did them. This is times right here. And I just went ahead and plugged them in the unit circle, got the values, and simplified it. All right, number 9. Take off the root 2's, factor it, and then once I'm here, I can split them up, find the individual parts. On number 10, I have a general solution, meaning this generates answers. So I start at pi over 12, and I add on this many degrees. Well, I went ahead and wrote it with the same denominator, so look what I'm doing. I'm starting at 1/12, 5/12, 9/12, 13, 17, 21, 25, and I keep going until I'm past 2 pi. 25 divided by 12 is more than 2. And I went ahead and simplified down there. Number 11, a little bit tricky. After you do your even odd identities here, you have cosine plus sine, and a lot of people don't know what to do when we get to here. Well, if you subtract over the cosine and then divide by cosine, on the left you have sine divided by cosine, which is tangent. On the right you have a -1. So then you can do your tangent. And remember, tangents always simplify down. Tangents are always 180 degrees apart. Number 12, you solve for x over 3 is equal to these 2 positions, and then what you have to do is multiply by 3. Times 3 here makes it 3/4, times 3 here makes it 6. Do the same thing on the bottom one. everything in here is getting times by 3. All right, and on the last page, general solution again. Here we go. We start here, and we add on this much. So we start with this one. I went ahead and converted this to common denominators. And look what happens after I add on 4 pi. I'm up to 7 pi. Well, look at what my interval is. My interval is just pi. So 7/6 is already more than 1. So that is eliminated from our solutions. Number 12, we have a triangle that we can draw. The tangent is equal to negative 5 twelfths. I put the negative with the 12. It's in quadrant 4. Remember your quadrants are 1, 2, 3, 4. And then now that I have a picture, I'm asked to do this problem right here, sine of 2x. Well, sine of 2x is this formula here. So I just go ahead and plug it in. There's my sine value. I pick it from here, opposite over hypotenuse. There's my cosine, adjacent over hypotenuse. And then I just do the math. Problem 15. Well, that looks exactly like this tangent formula here, this top one where I just subtract the tangents. So I'm just going to subtract the tangents and put it back together all the way down to pi, and now I can do the problem. Sometimes you can do the problem as this. Sometimes you can do it this way. You just have to be able to do it both ways. We're going to go from the formula down to the single. A lot of problems we go from the single to the formula. But in this case, it's easier to do that. It's 0. All right, one problem that is on your test, you need to know this proof right here. We have a lot of rules. We have a page full of rules, and all of these come from somewhere. There's a reason for every one of these. All right, so we're going to prove this. We're going to verify that 2 theta is really the same as 2 sine theta cosine theta. It's that first one right there. We're going to prove this. This is true. All right, watch the logic here. I start with sine of 2 theta. That's given. Again, this is my left-hand side, and I'm going to turn it into the right-hand side. Well, 2 theta means theta plus theta. That's simple addition, right? I just broke them apart. 2 theta means theta plus theta. All right, well, what is theta plus theta? Well, that's this formula here. A plus B. A is theta, B is theta. So I do sine A, cosine B. Cosine A, sine B. Sine cosine plus cosine sine. I should have wrote these backwards. If I'm following the formula exactly, let's see if that's right. Sine, cosine, cosine, sine. Sine, cosine, cosine, sine. And then notice what I have here. These are both the same. This is sine, cosine, cosine, sine. So this is the same and this is the same. So I have 2 sines and cosines because I can flip the order here. This doesn't matter. Sine, cosine, cosine, sine makes no difference. So there we have it. And that's where this comes from. I have 2 of these terms here. So this expression is the same as this expression. And then when you start doing your work, sometimes you'll have this be the path you need to go on, and this might be the path you need to go on. All right, hope this helps with review number 1.